The physics of guns. What I wanted to find out is how much energy is in a bullet. I also wanted to find out if this amount of energy changes with the caliber of the bullet. What I did to find the kinetic energy of this bullet is I used the equation Ke equals half mv squared, plugged in the mass and velocity of the bullets to find the total energy. Using the same equation for kinetic energy, I found the energy of the 9mm bullet to be 471.14 joules. I found that the energy of a .357 Magnum round was 774.4 joules. Using the kinetic energy equation, I found that the 7.62mm round had 2,108 joules of energy. When a gun is fired, the bullet and shooter have the same amount of momentum, according to the law of the conservation of momentum. The shooter's momentum is given by m shooter times v shooter equals the mass of the bullet, m bullet, times the velocity of the bullet, v bullet. Because the shooter has so much mass and the bullet has so little, the mass of the shooter will be larger and the velocity will be smaller. Whereas the bullet mass is very small and velocity will be very large. For example, using the masses and velocities of the 7.62 round bullet, using this equation, we can find the velocity of the shooter, aka the recoil, is 0.129 meters per second, which is significantly less than the velocity of the bullet. Using the data from the 7.62 round bullet, we can calculate the distance the bullet fell during its traveling. First, what we need to do is find the time the bullet was in the air. And we can do this by finding the distance traveled, horizontal distance, divided by the velocity of the bullet. So that's 100 divided by 730.3, and that comes out to 1.137 seconds. Then we plug this into the projectile motion equation to find vertical distance. Once we do this, we find the bullet fell 0.09 meters. So that means I hit 0.09 meters below the target I was aiming for.